Okay, so we are back and we are in section 2.1 and 2.2. This time we're looking at shear strain. This is example number 1, and just really quickly, we had normal stress, which is caused by perpendicular to the cross section. You can't see that. And we end up with a change in length delta, which equals length final minus length initial. And then we had strain. So normal strain was delta over length original. Okay. Now we have shear. So shear, it could be caused by a normal force, but we're looking at a force that's now parallel to the cross section if this were a block. Okay, can you see that? And now we have skewing. So as we have this shear force, we end up with shear strain. Okay? So we have this shear force V that causes sides QS of the thin rectangular plate to displace downwards at 0.0625 inches. Here we go. So literally this could be like, here's our brake pad. Here it is attached, we've clamped it, and now it's coming into contact with the rim of the bike, squishing in on both sides, and we have this normal force, this tire that's wanting to come forwards. We're stopping. It's now parallel to the cross section of the rubber pad. It goes rink as we stop. Okay, shear strain. So just key things to remember. If I go in this direction, this is positive shear strain because I have pi over 2 minus theta prime equals shear strain. Okay. Negative. If I have that same rectangle and I skew this direction, okay, we can see that we still have pi over 2 minus theta prime. Theta prime is now bigger than 90 degrees, so we end up with a negative shear strain. Okay, so we can look at this, and I can already see that on this side, so this side would be a positive shear strain. This side, because we got bigger, we can visually see that it's negative. Okay, so I can say that tan theta equals, okay, well, let's just stop for just a minute. I said in our theory video that with small strains, we don't have to say that tan gamma equals delta over L, that we could just say that gamma equals delta over L because of small strains. So let's just look at that. If we say that tan gamma equals 0.0625 inches over 8 inches, and we go through this, then we find gamma is 0.4476 degrees, but the units have to be in radians. So gamma equals 0.007812 radians. Okay? Now, if we assume small strains, then we can just go straight to gamma equals delta over L. So gamma, that is not a gamma. I don't know what that is. Gamma equals 0.0625 inches divided by 8 inches, okay, equals 0.007812, and the radians are the unit. So I can go through and find gamma as an angle in degrees and then bring it back into radians, or assuming small strains, which hopefully that's what we have. I mean, really, to scale, we wouldn't be able to see that. Like this is, if this is 8 inches, this is not to scale. Okay, so there is gamma. I know it's negative because I can look at the picture and see that theta started out here. Here's my pi over 2, and we are now here. So if this is theta prime pi over 2 minus theta prime equals 0.007812 radians. And I can see that that gamma has a bigger, so there's our answer. So small strains, we can just take the delta over L, and we immediately get our answer in radians.